Yep, so we're now starting trig, and as you should have, you are looking in your book right now and seeing that we have done this first notes. But I just want to do a quick review. Now we're going to use that first sign a lot. This is theta, because that's always going to be your unknown angle in a, yes? It's in my book right now, so you can come do it later. Okay? This is similar triangles. This is congruent, meaning the same. This is not equal. This is what we use for the angle sign. Okay? This is what we use for triangle sign. This is what we use for approximately equal to. Okay? We're talking about, remember, opposite angles are always equal. For when you have parallel lines and you cut it with a transversal. Actually, I should have, these are actually opposite angles here. I don't know why I did that with your group. But these, you might want to change this in your group. These should be like y's, right? Because they're actually opposite. So they would be the same, right? Parallelogram we talked about. Remember how to label your sides and your vertices. Your vertices are always capital letters, and opposite them will be the lowercase of them, okay? So if you were standing there and you had a bow and arrow, the side that you would hit would be the side that you're going to give the lowercase to. Okay, Pythagorean review. Okay, we went through a bunch of that, and we went through how to also solve for A and for B. Okay, remember that the altitude and base always share the right angle. And we did, remember, Darth? Okay, then we did a bunch of these, and you've been practicing them. Okay, and then we did a word problem, and we didn't do this one. We worked on a problem that sometimes you have to solve for one triangle, and once you get that, you can solve for the other triangle. Okay, oops. So now we're actually going to go on to lesson 2. Types of triangles. Okay, so you guys have a bunch of writing before this though, right? There we go. So here we should be, right? Does that look right? Okay, so similar figures. I'm just going to do a drawing first. Now these would be similar figures. Now why don't we call this A, this B, and this C. Call this D, E, and F. Okay, now if that was this would be B, this would be A, little a, and this would be little c. This would be E, little d, and F. Now similar figures are same shape, but different size. Oh, sorry. Okay, but angle A would equal angle D. Angle B would equal angle E, and angle C would equal angle F. Now, but one thing is you'll find that the ratios will be the same. So like A over B, if you took A divided by B, that would be the same thing as D divided by E. Okay, so the sides are in ratio. Okay, and we'll talk about that more later. This is just kind of going over it quick. Congruent figures are the same shape, and size. Okay, now your vertex or your vertices in a triangle, all, so say we have A, B, C, angle A plus angle B plus angle C would equal 180 degrees. Okay, but these are the vertices here, here, and there. Okay, so like I just said, the angles of a triangle always add up to 180 degrees. Squares, parallelograms, and other four-sided figures all have an angle of 360 degrees. Now, of course, the looming question is, in math, a lot of the stuff we do, you know, when would I ever use this? Okay, your measurement unit you're going to use a lot. The trig unit is the most used of all of the units day to day for anybody that is in any kind of construction, or they're an architect, or they're a developer, right? They're in the trades, all those things. Trig's used quite a bit. All your surveyors need to know their trig, etc., etc. Okay? Now, we have different types of triangles. Okay? Now, we have a triangle that's like this. And this would be called an acute triangle. And what does it mean to be acute? Yes? All angles less than 90 degrees. Okay, then we have something like this. We've got this one angle is larger than, what kind of triangle is that? Anyone remember? Obtuse, good. So the next is the obtuse triangle. So one angle is greater than 90 degrees. Okay, we have one where they're all the same. And if they're all the same, what would they be? Equilateral, but what would the angles be? Yes? 60, right? So this is called an equilateral triangle. All angles are equal. Okay, and there's only one more triangle that we haven't talked about. Yeah, but isosceles would actually be an acute. Yeah, we haven't talked about scalene or isosceles. That's the other two, right? Scalene is with all different. Okay, so an equilateral, this is called a right triangle. One angle equals 90 degrees. Okay, and then we have this one here that you just brought up with two angles the same and these two sides are the same. This is isosceles. And then if we ever have a triangle that every side is different, this is called a scalene. Okay, so we're going to focus on this triangle in 10C. And then later you'll be working with obtuse and acute triangles to find angles. Now, the next thing that I'm going to show you is definitely, everyone get that down, is definitely super important, okay? So we're only going to study right angle triangles. All triangles must be right angles, or you must be able to draw right angles to solve them. In future studies, you'll learn different types of triangles. Now, the first thing that I want to talk about is naming our sides. Now, when we do Pythagoras, we do ABC. When we're dealing with sine, cos, and tan, have you guys done sine, cos, and tan before? Okay. Used to be in the grade 9 curriculum, and then they took it out. And that was a funny thing, because that's the one the grade 9s found the easiest. Yeah, this is a nice unit. I mean, if you miss the basics, you won't do well, but if you get the basics. Now, the first thing is naming a triangle. Now, there's 3 sides on every triangle that we're going to be doing. There is the opposite. There's the adjacent. And there is the hypotenuse. Before you do any of these, you want to label them right. Now, the hypotenuse, you guys know what that one is. If we look at this triangle below, right? This is the hypotenuse. Now, this is my unknown angle. Okay? We're not talking, is it asking anything about this angle? No. So from this angle, if you were standing right here, if you were to shoot an arrow, you would only hit one side. Okay? You'd skim here, and you'd skim here, but you'd only hit one side. Okay? So the side that you will always hit is called the opposite. And then there's always a side that is touching the right angle and the angle you're asking for. This is called the adjacent. Adjacent means beside. Do you see how this angle is beside this side? Right? And it'll always be joining these two. I mean, shoot an arrow. I didn't do a very good job shooting that arrow. It was windy. Okay? But the adjacent will be touching the two. The opposite will be directly opposite. Now, there's 3 formulas you're going to need to know. And the formulas are SO, CA, TOA. Okay? You need to memorize that. It's not hard. SOHCAHTOA. Okay? You'll be in a 4th year university class. You'll still be using SOHCAHTOA. I promise you. Okay? So what you learn here today, you're going to learn next year. You're going to learn next year. If you go to engineering, if you go to, take any math course, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. So you may think it sounds pretty infantile. A little, yeah, okay, that's kind of a, it doesn't sound very tough. But it'll help you get through all trig with right angle triangles. Now, it gets, because sine equals opposite over hypotenuse. Cos equals adjacent over hypotenuse. And tan equals opposite over adjacent. Do you see where SOHCAHTOA comes from? Okay? And here it is written out long. The sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse. And the tan of an angle is opposite divided by adjacent. Now, this is a lot to take in at one time. There's a lot of stuff you have to know how to do here. First of all, you got to know your 3 sides. You got to label your 3 sides. And you've got to know your 3 formulas. Okay? I don't even know. Are they on the... They might even be on here. Yes. Trig ratios right there. SOHCAHTOA. Right here. Okay? Now, the one thing that I will guarantee you is if you do not label your triangle correctly, you will get the question wrong. So the minutes take care of the hours here. If you don't do a good job setting up your question, you're wasting your time. You will get it wrong. You will be frustrated. You will try and blame some outside force, but I'll say you still don't know how to label your triangle. Okay? Now, instead of just going crazy, I'm going to teach you how to use tan. I'm going to teach you how to use your calculator. Okay? Now, if you have a TI 83 plus or a TI 84, there's something you need to know. Oh, good. Okay, so if you turn your calculator on, it's always important. And do you see the mode? Hit mode right here. Do you see where the arrow is there? Hit mode. Now, right now, is your calculator in radians? Go down to, is it in radians or degrees? It's huge. Nope. Radians or degrees, those are the only two. You got to make sure it's in degrees or you'll get these all wrong. You do not learn radians until grade 12. Yes? No. Only if you use sine, cos, or tan in your calculator. Okay? So that might be, I could say this at the beginning of every class. Make sure it's in degree mode. 10 minutes into the work, I'll have someone coming up and they'll go, Mr. Trimble, I can't get any of these. I'll go to their calculator. It'll be in radian mode. Okay? Then they'll sit down. Next class, we'll do another one. I'll have one student come up. Mr. Trimble, I'm not getting any of these. I'll go to the calculator. It'll be in radian mode. And they're like, oh yeah, crap. Okay? And as you can see, on all the TIs, every time you come in here and write a test, you're going to have to clear all your memory. Okay? And this is what this is. You may have wondered, what does that mean? That's how you clear your memory in your calculator. So on Tuesday, I'm going to stand at the door and I'm going to go, whoa, whoa, you can't come in. And you're going to show me mem cleared on your calculator. And because you're going to have to get used to it. Every single test that you will write, you'll have to clear memory before you. That means you can't put a bunch of formulas in. You can't put if you're savvy enough with your calculator, you can cheat like crazy with it, right? When you walk into the diploma, you have to clear memory before you walk in, right? I'm training you for that diploma, every little thing, right? If you're walking to the diploma going, clear memory, how do you clear memory? I don't know how to clear memory. I mean, that'd be weird because you're going to clear it all through grade 10, all through grade 11, and all through grade 12. I'm hoping by you get to the diploma, you know how to clear memory. Yes? Yes. That's where I was going with that. So clear memory, then bang, you've got to hit mode and get to radians. Okay, well yours, I'll have to look at it because it's not a TI-83, right? So. No, that's not clearing your memory. I'll look at it in a bit. Okay? Anywho, let's okay, I got two calculators open here. Okay, so let's get back to notes. Okay, so let's learn how to do these. Okay, so here is an angle. It's 23 degrees. And it is asking me for A. So now with using trig, we can find out sides if you give me an angle. Do you see how you can't use Pythagoras to help you out? It's not going to help you there, right? So can you please label O, opposite, adjacent, hypotenuse on your triangle before I do it and see if you can get it right. Okay, so you're standing at 23 degrees with your bow and arrow. Just that first one, okay? What is the 12? What side? Opposite or adjacent? I got two people. Is the 12 touching the angle and the 90? No. We're labeling the triangle. That's the opposite. This would be the adjacent. This is the hypotenuse. There's never two adjacents. Right in this one. Okay. Now, do you see which side has nothing to do with this question? Hypotenuse. Are we looking for it?
No.
Did they give me any information? No. See, I want you just to look at this right. No. So, ka, toa. Which ones need the hypotenuse? Right. So this is a tan question. Why? Because we have opposite and we're looking for adjacent. So we write down tan theta equals opposite over adjacent. You're going to be getting 1 mark just for writing down the correct ratio. You have a 33.333% chance, but you have to be able to know how to pick the right ratio. So you see, if you labeled your sides wrong, you'd pick the wrong ratio, you'd put the wrong numbers in, and then you would get the wrong answer. Okay?
Yeah.
So it's how we start, that's how we're going to finish. Now, the next thing is to fill in the information. So this would be tan 23 degrees equals opposite is 12 over adjacent. So that's just A. Now, is it clear that we're looking for A? Now I just want you to know this is over 1, okay? When you have a ratio equaling a ratio, meaning one fraction equaling one fraction, you have the ability to always take the escalator to move things around. You can never take the elevator, just the escalator. Okay? Now, what does that mean? See, the escalator goes like this. They can switch. So this would be A equals 12 over tan 23 degrees. Now they don't even just have to switch. I could just bring the A up here if I wanted. Okay? Like I'll just show you. Does everybody agree that 1/2 is the same thing as 2 over 4?
Yes.
Okay? Now if I just brought this up here, that's all I'm going to do. That'd be 4 times 1 over 2. Is that a correct statement?
Yes.
Okay? What if I'll trade the 2? Would 4 over 2 equal 2 over 1? Okay? See, it doesn't change it if you take the escalator. Yes?
No, it's an A. Just a poorly drawn A.
That's a poorly drawn 9, too. That's a really bad 9. I don't know what you're talking about. Okay, so this is how you put it in your calculator. Everyone do it. Just don't watch me. Okay, so you're in degree mode. Then you hit second mode to get out of there. That does your quit. So you have to go 12 divided by, you hit the tan button, which is right there, and you put 23 and shut the bracket always after you put the angle in. And that side, see, right there, right above the arrow. For what?
Yeah, clear is the basic things.
Oh, mine doesn't do clear. Like if I'm in here, well, if I was in this, if I hit clear, I have to hit second quit. Okay, so the answer would be
What do we route?
this one doesn't. This one actually just said do the setup and then cross multiply. But let's just do to the nearest degree. Is that what you guys are getting? Equals 28 degrees. Okay, now label this one. We're going to do this one here. Label it quickly. Oh, this one we're going to be using different ones. That's kind of good. Okay, so we're not just going to use tan. Now, what's the 24 clearly called? Hypotenuse. How about the x? And this one?
Opposites.
Which one of these has nothing to do with the question? opposite. So if you see so, ka, toa, which one would we pick? So cos theta equals adjacent over hypotenuse. Cos 34 equals adjacent is, no, what's adjacent? I labeled it. Look, x. Should be no confusion if you labeled it. If you don't label your triangle, good luck. Okay? And there's always one person that won't do it, and they keep getting it wrong, and they're whining, they're complaining, and it's just like people that walk into a room and it's really, really dark and they're bumping into things, and you're like, well, why didn't you turn the light on? I'm too awesome for that. I don't have to do that. Okay? So some people that they're too awesome to actually write that stuff down, they're getting it wrong all the time, and they're worried, they're wondering, they're confused. So what would be the hypotenuse? 24. Now what's the problem here? We need x by itself. So like I was showing you with that example, I could just bring the 24 up. So 24 times cos 34 degrees would equal x. So you want to get x by itself and up top. That's always the goal. Okay? What are we getting for that side? 19.89?
Yes.
Okay, holy, why did I write 28 degrees here? This should have been 28. Just the side, that's not degrees. We knew our angle. Okay, so what do we get, sorry? So 20. So 20 equals x. Okay, let's do this one here. Okay, label your triangle. Let's see if you can get your sides right. He's asking to come in. Okay, what is the x? Okay, who could tell me quickly how you know it's adjacent always? Who could tell me? Who can tell me? Yes? Touches the right angle and the angle. Is that touching the right angle? No. Okay? So it's either opposite or hypotenuse, but what is it? Hypotenuse. What's the 19? Opposite. And that's the adjacent, which has nothing to do with this question. Adjacent, right? So if you go so, ka, toa, we're going to use that one because it's opposite and hypotenuse. Are you getting this? Okay? No?
I'm confused.
Okay. Look up here for those. Adrian, why are you talking to him if you're confused? Okay? You got to look up here. That might be part of it. This right here. What is that? Do you get that that's the adjacent?
Yes.
Adrian, do you get it? Does it have anything to do with this question? Are they looking for it or are they giving us the adjacent? Did they give us the adjacent? What is it then? What's the measurement? Doesn't give it. Is it asking for this or giving this? Asking or giving? So do we agree this has nothing to do with the question? This has an A in it. Can't pick that one. This has an A in it. Can't pick that one. No, I'm not a genius. Pretty close, but no. Enough about me. Okay, so sine theta equals opposite over hypotenuse. Now you're going to know pretty quick when you start filling this in and you're like, I don't know them, right? Then you pick the wrong one. But hopefully you can pick it first. So you got sine, oops, not theta because we know the angle. Sine 42 degrees equals, what's my opposite? 19. And my adjacent, don't care, I mean hypotenuse is x. Okay? Nope. Oh, sorry, to solve, yes. Okay? What's my goal with x? By itself, not just by itself, on top. So if we did this, we would pull that off. Can you always take the escalator? Always. They're in ratio to each other. You're not liking this, I can tell. I play poker a lot, I know. That's a face that says, what are you doing? Right? This cannot be downstairs. And it's not by itself, it's got a 19 with it. If I trade these, do you see how it's upstairs and by itself? And that's always the goal when you solve. Okay, what is 19 divided by sine 42 degrees? What'd you get? So x equals 28. We could even put centimeters here because that one actually had centimeters in the... Okay, now, just in case you were understanding this, I'm going to throw some more at you. It wouldn't be fun if you actually got it right off the bat. Okay, so it says your calculator is your best friend. It should actually be your second best friend, right? Your math teacher. Thought that was kind of a given. So it's weird she'd ask. You're in high school now, not the end. Who's marking your test? Yeah, that's where you're nice to your math teacher. Okay, now we're back. Okay, the thing we're also that your calculator can do, because we've just been finding sides, it can also find angles, but there's a little twist when we find an angle. So I'm going to show you how to do that. Now, let's just write down, make a triangle. Now, this is going to be 7, this is going to be 9, and this is going to have the theta. Now, in all the other ones, they gave us that angle and asked for a side. What happens if they give us two sides and ask for the angle? And I still want you, from that angle, can you please label the sides, opposite, adjacent, hypotenuse? Again, this is the most important step. I'm not saying it's the hardest, but it is the most important, because if you mess this one up, probably it won't go well. So I just have always been in the habit, from here, I go like this and go like that. The 9 would be adjacent. See how it's touching the right angle and the angle, and this is the hypotenuse. Now, and then I do this. I do this for every question I do. I write that down. It's kind of like the kill him dead, right? Because it helps me make sure. Sometimes if I skip this step, I get it wrong and it's frustrating for me. Okay? So I can either be frustrated or take 10 more, that's not even 10 seconds, right? 3 seconds, I write that down. Now, do you see what has nothing to do with this question? Which letter has nothing to do with this question? H. So do you see how that and that, oops, not that one, bad. Those two will not be used. Why? Because they have H's in them. Well, I don't know H, and they haven't given it to me. So I'm not going to use it. So then I'm going to write tan theta equals opposite over adjacent. That's the formula I picked, and of course I'm going to give you a mark for that, because it is a skill to be able to pick the right one. Right? If you're going to guess all the time, you're going to be wrong 67% of the time, and that's not good odds. Now, then we fill in what we know. We don't know theta, but we know my opposite is 7, and my adjacent is 9. Now, it drives me nuts when students actually have labeled it. Look how the O and the 7 are there, and the A and the 9 are there. But then they'll go and flip it when they substitute it. And I'm like, but it says A9. Why'd you put it into opposite, right? So let's not be careless. Now, here's the twist. to find an angle. Okay? Because we haven't done that yet. So to find an angle, an unknown angle. Okay, these are my buttons that I will use on my calculator. Now, whenever I do buttons, I always put rectangles around them so you know that they're buttons. So we go second, you got to hit that one first, then tan, then I would go 7 divided by 9. And I should, usually it opens with a bracket, so I'm actually going to, and we're going to close the bracket, and then I'm going to press enter. Well, just watch when I do it. So, no, it doesn't go around, it goes like this, okay? So, if you hit second, and then tan, it always opens with a bracket. I'm going to shut that at the end, okay? At the end. And then all you have to do is go 7 divided by 9, shut the bracket. So you will get 38 degrees. So okay, so I'm going to just take this screenshot because I want you to be able to see this. I'll just make it a bit bigger. Okay, so you can see exactly how I had to use tan, and it's going to put a little -1. That's tan inverse. You're always going to use tan inverse, sine inverse, and cos inverse when you're looking for an angle. Okay? So, to find an unknown angle, make sure you use second. Okay? So, I don't know how many arrows you need to put here, but you could not put too many. That's too many. Okay, let's just go down to number 2. It says find, using the tan ratio, find the other 2 angles. Okay? So we're basically going to be doing this question twice. So if you could just draw this over here, because we're going to do 2 different questions. This is D, F, E. We know this. This is 4 and this is 3. Now it says find all the acute angles. So the first time I'm going to use that as my, since I am finding that one, what is the 3? What side is that? That's the opposite, and 4 is? Okay, and you can see which side has nothing to do with this question. So I'm not going to use so or ka. So I'm going to use tan theta equals opposite over adjacent. We always want to write down our formula first because you'll get a mark for that. Then tan, I don't know theta, I will leave it as unknown angle, equals opposite is 3, adjacent is 4. Okay, what am I going to put in my calculator? No. Second tan, 3 divided by 4. So is it difficult? No, but when you're on a roll and say you've been finding a side, finding a side, finding a side, then they throw an angle in you, that's when students usually forget. Because they've been doing something for a while and then bang, they want to find an angle. So you should get, are we going to the nearest degree? 37 degrees. So you'd go theta equals 37 degrees. Now, so I found that angle. Now, do you see that now, on this one, if I want to find this angle now, what is the 4? Is it the adjacent anymore? See how it turns into the opposite now. I'm finding a different angle. If I was using the same formula to find a different angle, that would be weird, right? You would be sitting there going, okay, I sort of get it, but... And the 3 now becomes the adjacent, and hypotenuse still has nothing to do with this. So it's tan theta equals opposite over adjacent. Tan theta equals the opposite is 4. The adjacent is 3. Okay, so if you put that into your calculator, second tan well, it's second on the calculator, so tan inverse, I'd have 3 hands up going. How do you do that again? So 53 degrees. Now, does that make sense? What do these add to? No. These add up to 90 degrees. What's the other angle? 90, 180. Now, maybe some of you right now can see why students, like, I'm not trying to actually be, sarcastic, where students really like the trig unit. Like, some students love the trig unit, right? And they just can get it, and they understand it, and, right? So when they took it out of grade 9, because it used to be in grade 9 for years, like 20 years, and then they took it out. Even grade 9 math teachers were like, oh crap, the one unit they loved, they took out and put into high school. Why do the high school teachers get everything, right? But, so I can't answer that. But anyway, okay, support cable. We're going to do one more. Support cable is anchored to the ground from a telephone pole. Okay, so here's our pole. Okay, and it's anchored to the ground, and it's 5 meters long. Or no, sorry, it's anchored 5 meters from the ground, and it's 19 meters long. Okay, and this is 5 meters. It asked, what angle to the nearest degree does it make to the ground? So it wants this angle right here. Now, if this angle here, see, it's from the ground up. Just so you know, this is also called the angle of inclination. It's the incline, okay? What's the incline, right? That might be walking up a mountain. That might be driving up a road, right? There's an angle of incline. Okay, now, let's label our triangle. What is the 19? Hypotenuse. This would be the right angle, right? Again, it was a strong wind. Oh, so it may look like it's tilting a little bit, but it's from the ground. It gives a little bit. Okay, what is the 5? Adjacent. What's the pole? Which formula has nothing to do with this question? So, O has nothing to do with this, so we're not going to use. So we're going to use cos theta equals, what does A stand for? Adjacent over hypotenuse. Cos, the unknown is theta, so I'm going to put that. The adjacent is 5 meters. The hypotenuse is 19 meters. See, I'm just substituting right from my correct. Now, since we're finding an angle, what are we going to do? Second cos 5 divided by 19. Okay, and this asked to the nearest meter. So this would be theta equals, or not, I didn't ask for the nearest meter, to the nearest degree, 75 degrees. Yes?
Is closing up the bracket a necessity?
No, it's not a necessity, but there'll be other times in math that it is a necessity, so if we do it all the time, you'll never get it wrong. Okay? So I don't want to play the, oh, Mr. Trimble, I got confused. I thought this time you could leave it out, this time you couldn't. But if I say do it all the time, it'll never be wrong. Right? And that's what we want. Right? We always, Sometimes students, they do this, they get confused between not understanding the math and not understanding those small little things that are killing them, right? Like not rounding their units and not closing brackets and not, when you divide and two things are in the bottom, they don't put brackets. Like they did their, drawing perfect, they did their formula perfect, they did their substitution perfect, but they don't know how to use their calculator correctly. It gets discouraging after a while, okay? And I don't obviously want that for you, so. Okay, so we're going to, it's weird. Okay, I'm actually going to get rid of this, and we're going to do page 75, 3, 5, 8, and 10. Okay, and I want you to do all, like 3 will have like A, B, C, D, but they're going to be fast. Okay, keep an eye on your notes. Make sure you're doing formula, substitution, answer. Don't get in bad habits. You're going to come do a quiz. I'm going to be looking for that. You're going to be like, oh, I didn't do that on my homework. Well, you need to do it here.